Okay, let's verify some solutions for differential equations. What does it mean to verify? We just make sure or demonstrate that something is true, accurate, or justified. So let's go. It's not going to be hard. Verify that this function is a solution to this differential equation. A differential equation is an equation that involves a derivative or a slope. Clearly there's a slope involved. Clearly there's a slope involved. Clearly there's a slope involved. What's that 4 doing there? I'll tell you later. So let's move on. Verify that this function is a solution to that. Well, y prime prime. Oh, but then I need to find the second derivative. Okay, that works. We'll find the first derivative, negative sine. Then we'll find the second derivative, which is negative cosine. Oh, good for us. Great. Now, we're going to plug that negative cosine in for y prime prime, second derivative, plus y, which is just cosine, and we get 0. And I would like to think that we're done. I do want to go a little bit further. I want to be like, oh, negative cosine plus cosine is 0, so 0 equals 0. Check, verified. Really, that's it. You don't have to be like, I have verified it using thorough mathematical proof, and you know, that's all. We got a true statement. It is verified. I like to put a check just to demonstrate. Okay, sliding up to the next one. This one's going to be the chain rule. Verify that this function is a solution to this differential equation. Whoa, what? Okay, I need the first derivative, and I need the fourth derivative. So I'm going to have to find multiple derivatives. So let's find the first one. The derivative of e to the 3x is, well, e to the 3x, chain rule, times 3. Okay, we're going to need the second derivative. We're going to need the third derivative. I'll start using that. That's what that means. How do we know that we are dealing with a third derivative and not y to the third? The parentheses give it away. I don't know if you can hear this, but there is the sound of something outside. It sounds like hail. So H-A-I-L, just to clarify. So I think we're having a little bit of a storm. It's kind of dark outside, so I think it's hailing. Y double prime, it didn't sound good when I said it, did it? All right, y double prime is 3e to the 3x. Take the derivative of that. Unless there's lots of like middle schoolers throwing rocks at the window and I don't even realize it. Yeah, at 5:30 on a Friday, I doubt it. The derivative of e to the 3x is e to the 3x. We will multiply by 3. We had a 3, we get a 9. There's a pattern that's going to emerge here. I talk louder than the rocks being thrown at the window. Can you hear this? Put it in the comments if you can hear it. Kidding. Oh my goodness. All right, we have e to the 3x. Take the derivative of that, multiply by 3. It's going to give me 27. I got to talk louder than that. See the pattern that's emerging? Notice. 1, 3, 9, 27. And we're going to multiply by the derivative of 27, and that's going to give me, sorry, not multiply by the derivative of 27. I'm distracted by the weather. So 27 times 3 is going to give me 81. You're like, stop the video. Go look out the window. Don't worry, I will. Minus 30, 3e to the 3x equals negative 9e to the 3x. And we will simplify this and confirm that it's truly a solution, verify it. And I don't hear it anymore. Barely, it's going away. So minus 90e to the 3x equals negative 9e to the 3x. And then we're going to do 81 minus 90. That gives me negative 9e to the 3x, which equals negative 9e to the 3x. And then no one paid attention to anything because you were worried about the windows and what's going on outside. But there we go. It is indeed verified. Here's what I was saying while it was so loud. As we take the derivative, we have to consistently multiply by 3, and that's just going to increase these. These are powers of 3. All right, now things get really fun. For what value or values of k does y equals cosine of kt satisfy this differential equation? So we need the second derivative. Well, let's find the first one first. The derivative of cosine would be negative sine of kt. Oh, wait, derivative of the inner part. This is chain rule, so we multiply by k. All right, we're going to do it again. I need the second derivative. So derivative of, let's just go ahead and take the derivative of sine. That'd be cosine of kt. Handwriting just got really sloppy, didn't it? Multiply by the derivative of that inner part, which would be another k. So we have, well, negative k times another k, so negative k squared. All right, we now have everything we need to proceed and move over here. So y double prime, that'd be negative k squared cosine of 4, sorry, not 4, kt, equals, there's your 4, negative 4 y, don't just put a y, you know what y is. It's cosine of kt. And we will proceed. I think it's fairly obvious that we can divide out the cosine of kt, assuming it's not 0, safe assumption for now, so we'll just go ahead and cancel those. So negative k squared equals negative 4, and so k squared equals 4, k equals 2 or negative 2. Okay, done with everything I was going to do in this video. However, I'm going to walk over to the window, see what's sitting on the window ledge, and show you, and it might be a huge disappointment, so hang around if you want to know what all that noise was about. Okay, you're going to be disappointed. It was hail about the size of a pencil eraser, and I tried to pick one up and it melted. So I picked it up, couldn't quite get it. It was stuck in the little window pane. Anyway, it was about the size of a window eraser. That was all I saw, just one little piece. I tried to find more. So anyway, and now the little guy walking, he's not a little guy, but the guy walking down the hall with the floor buffer is going by too. So it's just noise after noise. I hope you're learning something.